Okay, let's take a look at the warm-up. A septic tank has a spherical shape, so I'm going to underline spherical as we go through, with a radius of 7 feet. We want to know how many gallons does it hold. We're given a conversion here. 1 foot cubed, or 1 cubic foot, is approximately equal to 7.48 gallons, and we want to round to the nearest gallon. So on the right, we've got a little bit of scaffolding to help us work through this. So what shape am I working with? We circled that, a sphere. Next step is, what formula do I need to use? And I'm going to substitute it in. So the formula for the volume of a sphere is 4/3 pi r cubed. Okay, so I'm going to go over to the side. I'm looking for the volume. I know 4/3 and pi are just numbers, and I know the radius is 7. Okay, and now I'm going to type this in, and I should mention that it is 7 feet. I'm going to go right into my calculator with that. Remember, to get pi, we hit second and then the caret button. Caret gives us the exponent. And so I get this number here. And I can't round that because that's not quite my answer yet. I'm going to be rounding to the nearest gallon, but the problem is I have feet cubed right now. Which brings us to part C. Are our units correct? Okay, no, our units are not correct because we want to have gallons. So it says how many gallons does it hold. And so what we're going to do is we're going to set up a conversion. Remember, what we want to do is we have this equal to X gallons. Okay, and we're going to set up a proportion and cross multiply. We use our conversion, feet under feet, gallons under gallons. That way our units line up and we cross multiply, but when I do 1 times X, I just get X. And I'm going to take the number that's already in my calculator and just hit times 7.48. This way I'm not rounding. And I get a new number. And this time I'm rounding to the nearest gallon, which means the nearest whole number. And so to the nearest whole number, the 9 makes me round up, so I have 10,747 gallons, and now I have the correct units. So notice we're not rounding until the last step. Okay? Pause the video if you need to take time to finish copying this down, or if you have any questions, pause the video and then call one of us over.
So now we're going to look at the volume, surface area, and lateral area of cones. So here we have our formula for the cones. We have SA, LA, and volume formulas. And let's look at our first example. So we're going to find the lateral area, surface area, and volume for each of these cones. Okay, first for the lateral area. We have lateral area equals pi r s. And up here we have, so r is going to be our radius. And s is going to be our slant height. So if we look here at our picture, we can find our diameter is 30. And that's across the whole thing. But if we're looking for the radius, it's only going to be half. So we're going to look at half of the 30, which is 15. So this will become LA equals pi times 15 times our slant height. So for our slant height, it's going to be this is 25. And we'll pull up our calculator. Oops. We're going to do pi times 15 times 25. Okay, so to put pi, we're going to do second and that caret symbol. Times 15 times 25. Okay, and we're going to get 1,178.09. We're going to round to the nearest whole number, so that will be 1,178. And we're working with inches. So it'll be inches squared. Let's move this so we can. Okay, now we're going to look at the surface area. So our surface area formula is going to be surface area equals pi r s plus pi r squared. If you look back, you notice that The lateral is going to give us this first part here. So I'm just going to fill in 1178 plus, now we have to fill in the pi r squared. So pi, and we know our radius is 15, so it'll be 15 squared. So let's pull up our calculator, and we still have that same number in there, so we'll keep it there so we're not rounding yet. We'll do that plus pi times 15 squared, and we will get, round to the nearest whole number, and get 1884, or 1,884 inches squared. For the last part, we're going to look at our volume. Look, I'm going to go over here. So I have room, volume equals 1/3 pi r squared h. And the h there is going to be the height. H equals height. So we're going to fill in 1/3 pi. We know our radius is still going to be 15, and our height is going to be 20. So we'll multiply by that 20. All right. I'm going to do alpha y equals to put in my fraction. Enter 1/3 times second caret is pi. Let's try that one more time. 1/3 second caret is pi. Our radius is 15. 15 squared times 20. So we'll get 4,712. And we're going to go ahead and round that to the nearest whole number. It'll stay the same. And this will be inches cubed because we're looking at volume. Now that we did one example, you're going to try the one on the right on your own and then replay for the next slide.
Okay, so at this point you should have checked in with us on the second example on the previous page, and if you have any questions at this point, call one of us over now. We're going to try a word problem. So suppose that the radius of a cone is 3 centimeters, so we're going to keep going with important information, and its surface area is 24 pi centimeters squared. Find the height and volume of this cone. We're actually going to change that up a little bit, and we're going to find the slant height, and then we're going to find the lateral area. So if you can change that in your packets as well. So again, breaking this down step by step, what information do we already know? Well, we know that the radius is 3 centimeters, and we know that the surface area is 24 pi centimeters squared. Okay, so our next step is there a formula for this information? Well, all of the formulas include the radius in them, but the surface area has a specific formula. So the surface area formula says surface area equals pi rs plus pi r squared. And so what we're going to do then is we're going to take what we already know the surface area equals, and we're going to substitute what we also know the radius equals. What you'll notice the only thing is missing is the x, the slant height, and that's what we're going to solve for, is the slant height. So we're going to simplify following our order of operations. Okay, I'm going to leave the left side alone for just a minute. On the right, I'm going to change that to 3 pi centimeters times s. And then exponents is my first step, so 3 squared and centimeters squared, I get 9 pi centimeters squared. Okay, as I continue to solve, I'm going to have to end up going over our space a little bit, but that's fine. I'm looking for my like terms. My like terms are, sorry, I missed my pi in here. My like terms are the ones with pi but no variable, so I'm going to subtract 9 pi centimeters squared from both sides. Okay, and that leaves me with 15 pi centimeters squared equals 3 pi centimeters times the slant height. Now remember, at this point, in order to undo multiplication, I have to do division. So I'm going to divide both sides by 3 pi centimeters. On the right, we do that so everything cancels out and we're left with just S, our slant height. On the left, think about it piece by piece. 15 divided by 3 is 5. Pi divided by pi cancels, and centimeters squared divided by centimeters cancels 1 centimeter from the top and 1 centimeter from the bottom. And so our slant height, which is just one dimension, is just centimeters to the first power. Okay, so we have 5 for that. Now that we have that information, we can go ahead and find our lateral area. So again, we have to look up a formula. Lateral area equals pi rs. Okay, and at this point, I already knew the radius, but now I also know the slant height. And so I'm going to go ahead and find that product, and I'm going to round this to the nearest hundredth as I go. So I'm going to type in pi, pick this up first, pi, times 3 centimeters times 5 centimeters. Pull that onto the screen. Okay, and I'm going to the nearest hundredth. So that's the second place after the decimal. That gives me 47.12. The 3 makes my 2 stay the same. And I have centimeters times centimeters, which gives me centimeters squared. Remember, anytime we have any type of area, it's always going to be squared or to the second power. Okay, if you have any questions, call one of us over. Otherwise, go ahead and pause the video and go to the next slide. You're going to try this whole problem on your own. When you're done, check in with us, and we will let you know if your answer is correct or if you made any mistakes. And then the last step is to answer the exit ticket. How are cone formulas related to cylinder formulas? Once you hand in your exit ticket, you can go ahead and start your homework. It is the last page of the packet.